Welcome to GeoWar News, your go-to source for cutting-edge military technology and global defense updates. A startling image has just emerged from Yemen, raising serious concerns within U.S. defense circles. The photo, taken by local civilians in the Aslan region of southeastern Yemen, shows the wreckage of an American-made GBU-53/B StormBreaker glide bomb, astonishingly intact, resting in the desert sands. This bomb, also known as the SDB-2 or Small Diameter Bomb 2, is one of the most advanced precision-guided munitions ever developed. What makes this case even more alarming is that the bomb appears to have failed to detonate upon impact. Its retractable wings are partially deployed, and the fuselage shows minimal signs of damage. It's likely the sand absorbed much of the kinetic energy, allowing the weapon to remain largely undamaged. The StormBreaker is designed to be one of the primary air-to-ground weapons of the U.S. and its allied forces for decades to come. It's part of a new generation of smart munitions, capable of being guided by a tri-mode seeker that integrates millimeter-wave radar, infrared imaging, and semi-active laser guidance. This allows the bomb to strike both stationary and moving targets, even in poor weather or through battlefield smoke and dust. In terms of connectivity, the StormBreaker can receive mid-flight updates via a data link, communicating with the aircraft that launched it. This makes it capable of shifting targets after launch or receiving fresh intelligence while gliding toward its objective. At high altitudes, it has a range of up to 111 kilometers, approximately 69 miles, giving aircraft the ability to engage from well outside enemy air defenses. Despite its sophisticated capabilities, the StormBreaker is compact. It measures just 1.7 meters in length and weighs only 93 kilograms. Thanks to this, stealth fighters like the F-35 can carry multiple bombs internally, preserving radar invisibility while maximizing strike potential. A single aircraft can engage a wide array of targets with surgical precision and reduced collateral damage. This incident in Yemen marks the first known case of a StormBreaker being recovered almost fully intact by hostile forces. In this case, the Houthi rebels, who are backed and armed by Iran. That alone is a major intelligence concern. But when we consider Iran's extensive military ties with China and Russia, the stakes rise dramatically. Sensitive U.S. military technology, including the StormBreaker's guidance systems, data link architecture, navigation algorithms, and explosive materials, could now be studied and reverse-engineered by America's most powerful rivals. Even subtle insights gained from this wreckage could contribute to the development of countermeasures, electronic jamming, or copycat weapon systems. Moreover, the StormBreaker is packed with classified or semi-classified tech components. Beyond the guidance system, it houses advanced microelectronics, inertial navigation tech, encrypted data receivers, and a compact warhead optimized for efficiency. For an adversary, this is a treasure trove. This incident serves as a stark reminder of a persistent and growing risk in modern warfare. Even the most sophisticated military systems, no matter how advanced or well-designed, are never completely immune to operational failure, technical malfunction, or unintended compromise. Today's battlefields are increasingly chaotic, unpredictable, and information-rich environments. In regions like Yemen, where non-state actors, backed by regional powers, have direct access to advanced weaponry and intelligence networks, the possibility of sensitive ordnance falling into hostile hands is no longer theoretical. It is a harsh reality. The deployment of elite precision munitions like the StormBreaker in such volatile theaters was always a calculated gamble by the United States and its allies. Commanders weigh the enormous tactical advantages these weapons provide against the devastating consequences if even a single unit is recovered by enemy forces. However, what we are witnessing here is not a routine battlefield loss. It is a rare and deeply troubling occurrence where a state-of-the-art smart bomb, almost fully intact, is now likely undergoing forensic examination by hostile experts. As of 2025, the strategic landscape has only become more dangerous. There are now widespread fears within defense circles that the StormBreaker's cutting-edge design, including its unique tri-mode seeker, data link communication systems, miniaturized electronics, and even its stealth-enhancing materials, could be leaked, reverse-engineered, or imitated. If Iran, a longtime supporter of asymmetric warfare and reverse engineering, shares this recovered technology with close partners like China or Russia, the potential consequences for future global battlefields are staggering. China, with its advanced military-industrial capabilities, has a well-documented history of adapting captured or studied foreign technologies into indigenous weapons programs. Russia, grappling with international sanctions and seeking to modernize its tactical air-to-ground arsenal, would also have significant motivation to incorporate aspects of the SDB-2 into future glide bombs or standoff munitions. This could lead to the emergence of new generations of precision-guided weapons capable of challenging Western air dominance in key theaters such as the Indo-Pacific, the South China Sea, Eastern Europe, and the Arctic regions. The risks extend beyond simple imitation. Adversaries could develop specialized countermeasures, jamming devices, or spoofing technologies specifically designed to neutralize or deceive weapons like the StormBreaker. Understanding the bomb's data link frequencies, encryption protocols, and guidance algorithms could allow enemy forces to create electronic warfare tools that compromise U.S. strike missions before the weapons even reach their targets. This would drastically alter the effectiveness of Western air campaigns, especially those relying on stealthy, standoff tactics. In response, the United States Department of Defense may now be forced to accelerate its programs focused on next-generation encryption, dynamic frequency hopping communications, and hardened guidance systems. There may also be calls for tighter restrictions on the operational use of highly classified munitions in conflicts where retrieval after a malfunction is unlikely or impossible. Some analysts are suggesting that new self-destruct mechanisms or remote neutralization systems must be integrated into future smart munitions to prevent technological compromise when failures occur. Furthermore, this event is likely to trigger a broader re-evaluation of export policies and the sale of advanced weapons to allies. Nations receiving cutting-edge munitions might face stricter end-user monitoring, enhanced operational guidelines, and mandatory battlefield recovery protocols. Lessons learned from the StormBreaker incident could redefine how the West manages the life cycle of its most sensitive and strategically critical armaments. Ultimately, the battlefield is no longer just a contest of firepower, it is a contest of information dominance. Whoever best understands the opponent's technology, tactics, and vulnerabilities will hold the advantage. The loss of the StormBreaker, therefore, is not just a tactical setback. It could represent a strategic turning point if the United States and its allies fail to adapt rapidly enough. Thanks for watching GeoWar News. Be sure to stay tuned as we bring you the latest in global defense, military technology, and strategic developments from around the world.